Good morning, everyone. Thank you for joining our session back. We are back with a new session for 2025. This is User Group Data India, and I really looking forward to host you guys. So today in our session, as the topic suggests, we are going to focus around the real-time architectures leveraging AWS services, and we have a special guest from AWS to help us around her experience from the market, from the trend, from the ground. What are the different services? How customers do use it, and what are the different best practices? So today the speaker is Annie. She is a specialized data in AI, AWS India, and she'll really help us to understand, as I mentioned, the best practices and all. But hold on, before we pass on to Annie, there are a couple of things which I wanted to call out. AWS user groups meetups are driven for the community, by the community, and this is all over the place, whether you talk about India or globally. So if you are from anywhere part of the world, please do check out. There is a nearby meetup group and do join whenever you have time. There's a good amount of networking, learning, and fun you will receive with that. If you're still yet to subscribe to a user group, right, you can just look at the different benefits of why you should do it. And as I mentioned, there is a page available from AWS user group where you can look out the nearby location of the user group chapter and you can join. Just in case if you are based out of India and you're having some issue that which location, which user group, how I can participate, please don't hesitate, reach out to me, DM me on LinkedIn. I'll be happy to answer that. And if you're yet to fail to subscribe to our AWS user group, please do subscribe it now. We do have our Meetup, WhatsApp, as well as YouTube channel. So don't hesitate. Please go ahead and subscribe now. With that, let me get Annie on the stage. Hey, Annie, good morning. How are you doing today?
I'm doing good. Thanks, Sanchit. How are you?
Really fantastic, doing great. Thank you. And I really appreciate behalf of my community that you took out time from your busy schedule to help us
Very.
learn patterns. And we are really looking forward to your session. With that, let me pass on to you. If you can share your screen, I can bring up to that
Sure.
queue.
Let me know once you're able to see my screen. I just
Sure.
started.
Yeah, your screen is live and up. So I'll
Okay.
pass on to you, Annie. Best of luck.
Thank you. Thanks, Sanchit, for setting the context. Good morning, everyone. Thanks for joining this session. This is Annie Mattoo, and I'm a senior analytics specialist with the AWS India. Happy to have you guys here. So today the agenda that we have is essentially to cover what really data analytics means, specifically in a real-time scenario. We'll also talk about different ways of doing real-time data analytics. I'll also talk about various offerings that AWS provides for streaming data services. We'll cover it up with various architectural patterns that we see customers adopting when it comes to real-time analytics, and we'll summarize it with few takeaways for you to implement that in your own scenario. So those are the few things that we'll cover today. But let's get started. So before I move on, I think all of us are aware that real-time analytics is in the game, right? So whether it is you're buying new things online or whether products are getting shipped, all of it basically happens in real time. In fact, even if you have any kind of bad actors who want to get access to your data, that also happens real time. So the world essentially is moving in real time. And which is why if you're not acting fast or in real time, that is where businesses lose on those big opportunities that they might have. For instance, for example, if there is a fraudulent transaction that happens in the banking world, there is only merit when you do it in real time, or essentially when you're able to identify that transaction in real time. It doesn't make sense if you do it later on, right? So basically, when you look at insights that you derive from your data, it basically loses value over a period of time. It is perishable. That's what we say these days, that insights are perishable. Like various other things. So which is why we see more and more customers talking about the value of real time data and how they can act in real time. And this is specifically true because of the generative AI applications that people have started to look at, and essentially looking at ways to adopt generative AI in their organizations, right? So this is a brief survey that you can see on my screen, and most of the people agree to the fact that real-time data is something that they should definitely look at. Now, while we understand the importance of real-time data, what is it that basically makes it challenging, right? So if you look at it, there are multiple challenges, and it's not easy to adopt, and that's what we hear from customers also. And the challenges that you see come in various formats. So the first and foremost is that the data is coming from multiple sources. It is getting ingested in different formats. It's coming at various frequencies, and on top of it, if you have to do insights on your real time data, it's again a different kind of challenge altogether. And even if you're set out to do this, then you have the whole challenge of ensuring that your team is skilled enough or has the deep expertise to deal with real time data or streaming data that is basically coming into play, right? And that's not a very easy task. It's basically a very humongous task. On top of it all, you will see that there are a lot of concerns around data security, privacy, and other things that you need to take care of, especially when you're dealing with PII data or customers' data. And all of this basically makes it even more complicated to handle. And this is why what we see today is an emergence of streaming technologies. Now, when I talk about streaming technologies, what these basically do is it helps you gather and essentially harness all of your data in real time. It helps you derive insights in a faster way because you're essentially kind of creating a communication channel between your producer, which is kind of creating your data, and your consumers, which is actually reading the data. So essentially, with these streaming technologies, it basically makes it easier to adopt real-time analytics, and that's why you see a lot of companies investing in streaming technologies and ensuring that they are able to act in real time. Now, while there have been real-time analytics kind of use cases that has been around for a while, especially if you are using channels like Netflix or for that matter Prime Video and other things, you would see that there are these personalized insights or personalized recommendations that keep appearing for you based on your behavior, based on the way you're interacting with your content, right? So it's been around for a long time now. But what has changed? So the change that we are seeing is essentially with the advent of generative AI, because more and more people want to make use of generative AI technologies, and generative AI can only be helpful if you are able to sync up your data in the real time and essentially are able to act in a real time. And that's where we see new emergence around real-time analytics use cases. Some of the examples of use cases that you see on my screen right now are people trying to make use of your IoT data to do any kind of predictive analytics, for example of maintaining their machines and equipments that are there on the shop floors or manufacturing plants and so on and so forth. It can also be about like I was talking about earlier about fraud detection in real time. It can be about creating those personalized experiences for your customer and so on and so forth, right? So there are a lot of newer use cases or newer ways of dealing with these use cases that we see coming into play. Now, while we understand the importance of real-time data, we looked at the emergence of streaming technologies. What I wanted to show in this session today is what exactly it takes to build this ecosystem. At and if you see, you basically have a source which is basically creating all of these clickstream data. It can be your IoT data. It can be your, for example, your sensor data, or it can be simply your logs that are coming from, say, social media feeds like Instagram, Facebook that you want to essentially act upon, right? So sources basically can be any of these. Now, once you have these sources identified from where you want to capture the real-time data, essentially a lever that you will have to use is to ingest this data or collect these logs or these feeds in real time, right? Or basically, we call this as a streaming ingestion service. This ingestion service will help you collect these logs in real time. Once you have collected and ingested these logs, what you will also have to think about is a streaming storage. Because many a times what happens is that once the messages get translated or transmitted, there is a scope or there is a possibility of those messages getting lost in the middle, right? So you might have to redo or replay your data or retransmit your data, right? And which is where you need to have a buffer or basically a storage capability for these streaming messages. And this buffer can or the storage can also be used to replay your data at a later point in time, right? So which is where you need to have a capacity to store your data for some period of time. Followed by that, and this is basically true for real-time analytics. So once you have your data ingested and your data stored in some format, you will also have to do some kind of processing, specifically if you want to generate insights in real time, right? In case you are just moving the data or essentially storing it in batch format from here, because I see many customers doing that also, where they essentially move data from your streaming storage layer directly to the maybe data lakes, data warehouses, or any kind of storage component that they are using for analysis later on. But this is specifically true stream processing if you are generating real-time insights, and this is where you will either kind of aggregate your data or deduplicate your data, do any kind of processing that is needed to generate those insights. And finally, you will have a destination layer, which can either be a data lake or a data warehouse, or it can also be, say, for example, your dashboards that you want to build for your real-time insights, right? So this is basically how the flow looks like from your producer to your consumer when you're thinking about real-time data. Now, while we have understood this whole data flow and the life cycle of streaming data, what is important to understand that there are many open source technologies which have already been around, and this has been around for a while, right? So, for example, the most commonly used is Apache Spark, you have Kafka, and so on and so forth, right? But while you have these streaming technologies in place, we need to understand that there are few issues when it comes to use of these streaming technologies, specifically the open source one. And the first and foremost is the operational overhead that is associated with it. It's not very easy to use. You need to have some kind of deep skills to understand this, implement this in your ecosystem, and on top of it, you will have to also do various kinds of infra management kind of activities, like ensuring that your storage is provisioned, your compute is provisioned in the right way, and so on and so forth. And you will have to also take care of security, patching, configurations, and those kind of things. All the admin kind of activities associated, and especially when it comes to scaling, right? To ensure that these technologies or the use of these technologies helps you scale in the right way when your data volumes are increasing or decreasing, or you have those spiky workloads coming in, right? And also ensuring that your applications which you are building with your streaming data are highly reliable as well as available at the right point in time. Those things become a little difficult to achieve when you are doing it in using these open source technologies, and which is where essentially AWS provides a lot of services around streaming services, right? So I've tried to map our services across the data lifecycle that I was showing you earlier, and it becomes easier to understand what is there for what particular process, right? So as you can see here, the most popular and the most commonly used services are Kinesis data streams, which is basically Amazon KDS. You have MSK, Managed Kafka, streaming service for Kafka, which helps you with your stream ingestion as well as storage. You have Apache Flink, which is an open source service. So we also have a managed service for Apache Flink, which you can use to process your data. Here you can also use something called as Kinesis Data Analytics, which I have not called out here, but that is another service that you can also specifically use if you want to do any kind of analytics on top of your streaming data. And at the bottom, essentially, you have other services. The most commonly referred to is the data warehouse, the data fire hose, which basically helps you push the data to your destinations, right? This is specifically when it comes to your messages and data that is originating from your various sources, but it can also be data like your video data or those kind of things, for which we have another service called as Kinesis video streams. I would urge you to look at that particular aspect if you are looking at handling your video or images kind of data. But today's focus would be more around these services that you see on the screen, and I'll try to talk about these services in detail and try to explain what these particular services do and when to use what. And I'll also try to cover some of the latest features that we have announced as part of these services, which can help you, conceptuate in your ecosystem how these will be beneficial for your use case. So moving on, I think before I step further and deep dive into some of these services that I called out, it's important to understand that one of the most important benefit that AWS offers when it comes to its services is the price performance, right? We basically are the company who has provided price reductions over the last 10 years over and over again, which is generally not the case that you see out there. And we also, what we do is ensure that our customers are able to adopt our services in the most reliable and the most feasible way, by ensuring that the applications are highly available, reliable, and so on and so forth, right? So all the metrics that you see generally associated with other services that AWS provides, those are applicable to our AWS streaming services as well. Moving on, so the first service that I'll talk about is the Amazon Kinesis Data Streams, the KDS. We call it as KDS. But if you look at it, essentially, KDS has a concept of streams and shards. So as you can see on the screen here, you have multiple producers and you can have multiple consumers on the right side, which are basically consuming your data. Now, within KDS, like I said earlier, there is a concept of streams and shards. The producers, which are on the left side, generally will push a log or any kind of messages that they want to stream to a Kinesis data stream, right? So that's basically how it happens. And essentially, your consumers or the applications which are built on top of KDS, they will consume the data from these streams. Now, within a single stream, what happens is that there are multiple shards that get created. Shards are nothing but think of those as internal queues, which are basically storing your data. Now, within a single shard, the way the data is stored is we call it as a data record. And essentially, within a data record, you will have a sequence number, you will have a partition key, and you will have a data block. Now, a data block, essentially, the way it works is each shard or each data block can have 1 MB of data written over it. So a single shard or each shard can essentially ingest 1 MB of data per second, and it can support up to 2 MB of data per second of read throughput. So if you have to basically configure a KDS stream or an ecosystem, what you will have to look at is essentially the throughput requirements that you have for your use case. Your throughput could be both from your write perspective as well as from your read perspective. And keep in mind, like I said earlier, it has to be around 1 MB of data per second for each shard and 2 MB of data per second for your read. Or it can also be 1,000 records of per second and 2,000 records essentially per second for your read, right? So that's how essentially the data gets stored. Now, within KDS, the way we operate is you will have two options. You will have an option to essentially use an on-demand mode, or you can also use a provisioned mode. The benefit that you will get is that if you're using a provisioned mode, you will essentially have to configure or basically figure out a way to define the number of shards that you need within a single stream. And that is an activity that gets taken care of by AWS if you are using the KDS ecosystem in an on-demand mode. So that's the basic difference. So in, like I said, on the on-demand side, AWS takes care of the number of shards within a single stream. And on the provision side, you will have to define the number of shards that you need within a single stream. But keep in mind, like I said earlier, that whether it is on demand or whether it is provision node, in both cases, you will have to look at your throughput requirements for your use case, both input as well as output, to define the number of shards and streams that you want to create for a particular data stream. Now, while we have spoken about this, if you remember earlier, I was also saying that KDS is not just for your ingestion, it can also store your data. So basically what it means is you can retain your data within your data stream for a period of time. Now, by default, what it does, it basically stores the data for 24 hours, but you can configure that data retention period and you can extend it to around 365 days. So that it's completely up to you based on your use case how you want to retain your data and for how long. And also, apart from this, keep in mind, while this looks a little complicated in terms of streams, shards, and the way it stores data, but the moment the data gets inserted into a data stream or a shard versus the moment it gets read from your consuming applications, the delay between this time is typically less than a second. Right, so it's very fast, all of this that happens, and essentially you're able to read your data from your consuming applications in near real time, or you can say real time, right? There are multiple producer applications that are supported today for your Kinesis data streams, and there are multiple, like you can see on the screen, consuming applications, which are typically, it can be your custom applications also, which you are, say for example, using your EC2 compute to write your applications. You can use any of those to basically configure your KDS ecosystem. Now, essentially, it supports, like I said, all types of data sources coming from, say, IoT data, data streams, and all of those complexities. Keep in mind, KDS as an ecosystem is quite popular if you need a low-code kind of a solution, because it's very seamless to configure, it's very easy to use, and especially if you don't have a lot of expertise within your team to handle real-time data use cases, this is the service that I would recommend you to try and essentially use it for your use cases as a starting point. Also, since it's like I was telling earlier, it is a serverless service, which basically means that if you are using the service, the scaling and everything, based on your data volumes, happens in a very seamless manner. So this is basically about Kinesis data streams. Now we'll move to the next specific service, which is called as Amazon Managed Streaming Service for Apache Kafka, or simply put, MSK. Now, I don't know how many of you are already using self-managed Kafka clusters, but for those folks who are already using self-managed Apache Kafka or are used to, dealing with those type of setups, this is the game changer, because this basically takes away all the complexities in terms of managing your clusters, provisioning, configuring, tuning, ensuring that you are, not over provisioning it or under provisioning it as per your use case. All of those aspects are taken care of by MSK as a service, and which is what makes it a lot popular these days. And this is something that I see, especially the enterprise customers adopting. The primary reason, because MSK as a service or Kafka as a component essentially can handle unlimited volumes of data, virtually unlimited volumes of data. So if you're dealing with huge volumes of data or huge streaming applications that are pushing data into your ecosystem, MSK is the service to use. And essentially, since it is compatible completely with your open source Kafka, so as all the variations or all the updates that happen on the open source Kafka versions get applied on Apache Kafka also sooner or later. So it is, we ensure that there is complete compatibility between the open source Kafka and the MSK version of Kafka. Also, since it is a managed service, which takes away all of these overheads from an operational standpoint for your use case, which is why you will find it a lot easier to use. You will find that the performance using MSK clusters is a much better one when compared to your open source Kafka one. And also in terms of cost, you will see uh, on an average, we have seen around 40% lesser costs that people incur when they start using MSK as a service as compared to your open source versions. Now, within MSK specifically, there are three specific options that we provide. The first one is what we call as standard brokers. And this is basically, for those folks who want more control over their Kafka clusters, and which is where if you are using an existing setup, which is open source Kafka, it's very easy to migrate from open source Kafka to a MSK version using standard brokers. And if you know how to manage your clusters, and if you know the whole Kafka configurations and all, this is the best place to start. But what we also understand is not many people are prone to using Kafka, open source Kafka, and which is why for those people who don't have any exposure to Kafka setup, we have a different option called as MSK serverless. Serverless, essentially what it does is it takes care of all of your scaling and everything automatically. All you have to do is create an MSK cluster, and it will automatically figure out the right configuration for your use case based on the data volumes, based on the throughput requirements that you have, and you don't have to worry about anything here. And it automates, like you can see on the screen here, most of the tasks associated with MSK. And this is specifically for those folks who don't want any kind of operational overhead associated, and don't have the required say skills or deep expertise within their team to handle or manage MSK on an or basically Kafka clusters on an ongoing basis. What we also provide in the middle, and which is what we call it as express brokers. So this is think of it like a median between standard brokers and your serverless option, where basically if you want to get the right price performance and you also have some level of understanding of Kafka, and want to ensure that it is scaling at the right price point, that is where we recommend using express brokers for MSK. So this is somewhere between your standard brokers and serverless when it comes to the kind of control that you get over your Kafka clusters, the kind of automation that you get over your clusters, and so on and so forth. Right? It gives you, like I said earlier, the right price performance, and is the right point to start if you are new in this journey of managing streaming data workloads. Now, before I move further, let me also talk a little bit about, for people who are not aware of what Kafka essentially is, the way it works. The way the Apache Kafka, or for that matter, any kind of Kafka setups work is there is a concept of brokers, partitions, and topics. So essentially, you will have a cluster that you will create, and within a cluster, you will have broker nodes, which is nothing but one or more servers that will manage your data. And the way the data gets stored within each of these brokers is through a concept of partitions and topics. Now, partitions essentially is nothing but where you're storing your data, which is coming in the streaming data, into various partitions within your cluster. Now, within a partition, you have a concept of topics. What happens is essentially there is a named category that you create called as a topic, where you kind of group your similar messages in a single topic. So when a producer is streaming some kind of data, it can be any data like your web server streaming your log data for your clickstream analysis. Basically what it does, it will push your streaming data to a particular topic, and your consuming applications will essentially read from that particular topic. So it's very important to understand that it basically relies on the concept of brokers, partitions, and topics. Now, with MSK specifically, what happens is it is very, very easy to add or remove brokers, or essentially scale as per your workloads, which is not very easy when it comes to your open source versions, where you will have to take care of all of these things by yourself. So scaling is one of the most important factors which makes MSK as a service very reliable and very useful for our customers. Apart from that, when it comes to specifically express brokers or serverless or any kind of setup that you are using within MSK, what you need to understand is that there is a concept of partition rebalancing. So whenever there is new data that comes in, you will have to ensure that your partitions that you are maintaining within your MSK setup are getting kind of balanced, so that you are getting the right kind of performance that you would want from your MSK setup. And partition rebalancing is basically one of the core components of the Kafka clusters, not just for MSK, but overall, whether you are using self-managed Kafka or whether you are using any kind of complete solutions or MSK for that matter, which comes from AWS, partition rebalancing is something that you will have to take care of. And those are the things basically, which kind of become easier when you are using MSK as a service. So that was essentially Kafka, or basically the streaming service that we have for Kafka. We spoke about KDS. Now, moving beyond that, what I also want to talk about is a different service called as Firehose. So if you remember in the previous slides, a few slides back, when I was showing the entire data lifecycle, when we talk about Firehose, Amazon Data Firehose, essentially it can take care of all of your ingestion, transformation, as well as loading the data or basically uploading the data to your final destinations, which is where Firehose is also something that people look to adopt, because it makes the task of the entire journey a lot simpler, right? It can consume your data whether you are using MSK or whether using KDS, which I explained about, in the last couple of slides. It can essentially, consume data from those services, do any kind of transformations, processing that you would want, right, for it to be applicable for your end destination, and you can load it back to your final destination, right? So it can do all of those things as part of this service. What it can also do is, not just KDS and MSK, you can also extract or basically ingest your data, streaming data, coming from, say, your IoT devices, your CloudWatch systems, or any kind of open source agents that you have configured in your system, which are collecting your streaming data. It can basically hook onto any of those things and essentially load your data in final destinations, right? And the list of sources that it supports, as well as the destinations that it can support, is ever increasing. So, which is where I would urge most of you, whoever are there on this call, to essentially look at this service and see if it is feasible for your particular use case. So this is a view of how Firehose works. So one of the key components that you need to keep in mind is, while it can use any of these data sources to ingest, store, and load the data, one of the new announcements as part of last year's reInvent that we made was that Data Firehose can now also push data into your Iceberg tables. Now, Iceberg is an open table format, which is essentially used to store your data within your data lakes, and basically makes managing your Parquet files a lot easier within your data lake. And that's where there's prominence around Iceberg tables that you see in today's world. Now, within AWS, what we also offer is a capability. Think of it like a managed service for your Iceberg tables, which is again a new launch coming out of reInvent last year. We call it as S3 tables. So please do read about this. So this is basically giving you the ability to, create your Iceberg tables on top of your data lake in a quite managed way. So you essentially don't have to take care of any of the overhead associated with managing these tables. All of that gets automated with AWS, and AWS takes care of all the table maintenance and management kind of activities. Now, one of the features that we have released is that Firehose specifically can directly dump your data from many of these sources to your Iceberg tables, whether it is self-managed Iceberg tables that you're maintaining in the data lake, or whether it is your AWS managed Iceberg tables, which are called as S3 tables. In both cases, it can essentially load your data in your final destinations. What it also does is it basically makes use of Glue data catalog, which acts as your iceberg catalog in this particular scenario to essentially do this activity. And you can also enable any kind of fine-grained controls or access that you want to enable on your data lake, or the data that you're ingesting via lake formation. So ADF is also integrated seamlessly with your lake formation. So this is a new announcement that came after reInvent. So this also helps customers to ensure that your data is flowing seamlessly into your final destination. Moving on, so while we spoke about iceberg tables already, what you can also do is, on the source side, in fact, if you want to essentially hook on your Firehose as a service to your database applications, and it could be your self-managed MySQL kind of databases or Aurora instances that you're using, or RDS for that matter. So any kind of changes or database changes that you want to replicate within your data lake or your iceberg tables, that can be easily done with your data firehose now. So this was earlier not the case, but now you can in real time replicate all the changes that are happening. So for example, if there is a transaction that is getting captured within your transactional or OLTP systems like these, you can simply replicate those changes directly on your data lake using Firehose. Same way, the way you have Firehose dealing with data capture changes, database changes. We also have a connectivity now between your DynamoDB, which basically provides a DynamoDB streams as a connector to connect with Apache Flink. So Flink is essentially another managed service for Flink, which helps you do any kind of data processing that you might need on top of your real-time data or streaming data that you're ingesting. So if people are aware about Redshift, so Redshift is nothing, Amazon Redshift is nothing but a data warehouse on cloud, which AWS provides. So what you see here is a capability where you can directly ingest data via or basically streaming data via your MSK or KDS or anything that you're using in between to load data into your Redshift. Now, the reason this is important is many a times what happens is you would want to do real-time kind of analytics or real-time insights via your dashboards that you want to build. In that case, what you can do is you can directly stream your data into a data warehouse and have quick dashboards created on this, and this whole process takes just seconds to complete, which is why it makes it a very applicable use case for your real-time analytics kind of use cases. The thing that has changed since the last time when we had MSK is earlier, if you had to load data into Redshift as a data warehouse, you would have multiple intermediate layers. So you would have to configure a KDS or an MSK as a service to ingest your streaming data, then load it via Firehose into something like an S3 bucket, which is your data lake. And from S3, you would have to copy the data directly into Redshift. So there were multiple hops that were associated when streaming data into Redshift as a warehouse. Those are the things which are now eliminated, and now you can directly stream data into your Redshift for any kind of analysis that you might want to do. So moving on, I think we spoke a lot about streaming services. So the way it looks like in today's world is you will have multiple applications, services. It could also be your files or feeds that are coming from multiple places. And ideally, the way it works is that you would have two pipelines coming out. One is a streaming pipeline, which you would want to ingest to do any kind of real-time analytics. And here, while you see it all landing into data lake, this layer can also feed directly into your dashboards or your BI tools, so that you are able to get insights in a seamless fashion. But essentially, what I was saying is that there are essentially two pipelines that come out of it. So one is for your streaming data that you will use to load your data into your final destinations, or the other one will essentially be able to handle your batch kind of workloads. These batch workloads can be ingested. You can use DMS as a service or anything else here. But I haven't covered this part in detail in today's call because our focus was more on the streaming ingestion or the way you can ingest your data, process your data, to handle real-time data analytics use cases. Like I was saying earlier, you can basically load the data using iceberg tables, or you can use your S3 tables, which is the managed service for your iceberg, to ingest all of this, either streaming or your batch workloads into your data lake. To, and it can ultimately power any kind of applications that you want to ultimately use. Here, these applications, like I said, can directly feed to your streaming layer also. You don't have to necessarily consume it via your data lake. Now, while we spoke about streaming and streaming data, the importance of it, we looked at various services. What we also understand is, initially when I was talking about real-time data, we were talking about the importance of streaming data when it comes to generative AI use cases, right? So today, when you look at those large language models or LLMs that you're using, you would want to ensure that your LLMs are staying up to date with the real-time data that your organization has, and which is why for your models to stay in sync with your enterprise data in real time, that is where you will need capabilities or an easier way to sync your LLM models with this data. And this is the reason why we have launched a service called as a real-time vector embedding blueprints. So this is basically something that you would see as part of your MSK service. When you go to the AWS console and look for MSK, you will essentially see a new feature called as real-time vector embedding blueprints in your left pane on MSK, which you can quickly use to support any kind of vector embedding solutions that you want to create in real time. Now, this is again a new feature that was launched as part of reInvent. Now, and the way it works is, if you are following this diagram, so essentially what you do is you are creating an MSK cluster, which is kind of streaming your real-time data, and this MSK cluster essentially passes the information to your Flink. Flink is nothing but your managed service for Flink, which is able to process this real-time data. What Flink does essentially is it basically calls on Bedrock, which you see here, where you have all of those LLM models kind of available, right? So Flink will kind of use your real-time data to call your LLM models which are there over Bedrock, and ultimately it will store all of those informations essentially in OpenSearch, which is nothing but your vector store. And this is where you will create your embeddings and store your data. So all of this process that you see here is kind of abstracted for you. All you have to do is you will have to essentially log into MSK, create a real-time vector blueprint, and all of your real-time data in a real-time way gets stored in your OpenSearch as a service, which you can use to essentially with any kind of LLMs that you would want to use for your use cases. Now, if you look at it, the way real-time RAG kind of use cases work, and RAG is nothing but retrieval augmented generation, which is the most popular kind of use cases in today's world for your AI ML or especially generative AI applications. Now, the way it works is essentially you will have a data source which streams your data, and you'll process that data, you will generate embeddings for your data, and you will store those embeddings in a vector store. And once you store those embeddings in a vector store, you will essentially invoke LLMs or use any kind of user prompts to generate the context for your RAG applications. So all of this essentially gets taken care of, and all of these steps essentially are taken care of with this particular feature that you now have available within MSK. So requesting all of you to please go check this out, because this will definitely be helpful if you're trying to adopt generative AI in your scenario. So so far, what we have seen is I tried to give an overview about the various services that we have. We spoke about KDS, we spoke about MSK, we saw Firehose as a service. I briefly touched upon MSF, which is the Flink managed service for Flink to some extent. I also tried to touch upon Firehose along with various new features, and so on and so forth. Now, while we have understood the major streaming services that AWS provides, it's important to understand how these services can be applied in a real-time scenario, or essentially how customers are adopting this for their use case, which is where on the slide you see a, a very famous or a popular architectural pattern that we have seen customers adopting, and one of that pattern is specifically for generating your real-time recommendations. So this is basically an example of a customer who has put up this architecture, and if you see and if you're following my cursor, essentially this is a clickstream application which is generating various kinds of events, right? Now, what they essentially are doing is they are basically pushing these events to your KDS, which is Kinesis data streams that we spoke about, and through those ingestion cycle, they are kind of getting that data into S3, which is your data lake. But while they are pushing these streaming events to your S3 buckets or your data lake, but at the same time, what they are also doing is they are calling Amazon Personalize, which is an AI service which can help them generate personalized recommendations. So these streaming events are also in real time way feeding into Personalize as a service, and essentially the recommendations and the output from this is getting fed back to your application, which is generating the clickstream events. So this is how this is an example of one customer who is using real-time recommendations to fine-tune their customers' preferences and basically look at customers' preferences and behavior to generate these recommendations in real time. This is another example of a customer, and this is essentially the fraud detection system that was built, and this is the most popular one specifically when you're talking about a banking scenario, or for insurance services and those kind of things, where you want to identify those fraudulent transactions in a meaningful way and have them blocked as and when they are occurring. And which is why, because you want to have this detected in real time, you need to have some kind of notification service which can alert you when something is going wrong, and which is where in this architecture you see the use of simple notification service, which is nothing but an AWS service to notify you in case something goes wrong. Now, what is happening here again is, there is an event bridge which helps you, put rules around various events that are getting generated. So you are kind of creating a rule that whenever there is a threshold or whenever there is something which is out of the way that is happening, you trigger an event, and those events essentially are getting passed through your MSK as a service. Here, essentially, MSK is used as your streaming service provider, and via MSK, they are calling an AI service called as Fraud Detector, which is essentially helping them figure out whether the transaction is genuine or the transaction is not something that should go through. And in real time, they are essentially passing this information back to your notification service, so that the right people can get notified and stop the transaction in real time. So this is essentially an example of a fraud detection system that one of our customers has built. Same way, and this is specifically for your IoT data or your sensor data that originates from your medical equipments, or it can be from your car sensors or those kind of data that comes in. All of that telemetry data is something that you would also want to look at in a real-time fashion. And here in this example, essentially all of that data from the source systems is getting captured via your IoT components here, so that all of those edge elements are getting taken care of, because you would want to do some kind of analysis on the edge using ML models and those kind of things, which is where we have an IoT Greengrass as a component. But primarily, if you look at it, once the data from the IoT systems gets ingested, it is passed again through the same services. Here in this case, the KDS, Kinesis data streams, finally into Redshift, which is your data warehouse. And at the same time, what they are also doing is they are generating insights. They are using SageMaker, which is nothing but your place where you can build your custom AI ML models, and creating dashboards out of it to analyze those logs and see if there are any kind of insights that can help them maintain their equipment in a decent way. Apart from that, what is also happening is you are pushing these logs and events to your data lake, which is your S3 bucket, via your firehose. So ultimately, it's the same components that we saw earlier. It is KDS, it is firehose, and you're kind of pushing the data into Redshift or your data lake. And if you want to do your analysis in real time, you're also having a streaming lake insights generation via your OpenSearch service. So this is an example of another architecture for a customer that we have built. And finally, I mean, if I have to put it all together, right? So essentially, you have multiple streaming sources. It can be, like I said earlier, it can be your sensors, it can be your social media, it can be logs that are originating from your clickstream applications, or it can be as simple as your enterprise applications or databases that you have, which are streaming your data. Then you will have an ingestion layer, which can be anything for that matter. It can be your Kinesis, it can be your MSK, or anything for around those lines. Specifically, if you are using batch kind of workloads, then we have a service called as AWS DMS if you want to do it in a batch mode. But here, if you are doing mainly streaming, then it is MSK or KDS, which are the most popular ones. You will store the data in your streaming ingestion service, and the retention can be defined by you. Like I was telling earlier, it can be configurable in both cases. In case of MSK as well as KDS, you can configure how many days you want to retain the data for your streaming storage. And then you will essentially do some kind of processing on top of your streaming data if you want to generate insights, or you can push it directly to your data lakes, data warehouses, or OpenSearch as a service is also becoming popular to do any kind of analysis on your logs that you would want to do. Right? Stream processing, we spoke about Flink, which can help you do stream processing, and we have a managed service for that. You can also do processing via EMR Glue, which are the more popular ones for your batch workloads. But if you want to do some kind of Spark streaming, via EMR Glue, that is also supported today. And finally, you will have an outcome that you get. You can basically use in a real-time way to take decisions, right? So at the end of the day, the idea is that you are able to act in real time, and which is where all of these services come together to help you generate those outcomes. So basically, so far, what all I have touched upon is essentially various services that AWS provides, the ways you can ingest your streaming data, and ensure that you are able to make the best use of your services to generate those outcomes, right? So while we have spoken about all of this, I also wanted to take a moment to talk about our new unified platform that was launched again as part of reInvent last year. So Amazon SageMaker earlier was capable of only handling the AI modules. It could help you train your AI ML models, help you build your custom AI ML models, tune your models, deploy those models, or do any kind of ML ops that you would want to do on your AI side. But now it's much beyond that. In the new parlance, the Amazon SageMaker, and this is basically a new, think of it like a new platform which brings everything together. All the services that you have been using around AWS now will come together in this single platform for you to interact and for you to seamlessly use these services in a cohesive way and in a centralized manner. Earlier, the feedback that we used to have from customers was that while AWS services are great, but then there are multiple services and it becomes difficult to track which service to use for what, and there are these multiple Lego blocks that you have to use to build something like a data platform. So to address those kind of concerns, that is where we launched Amazon SageMaker as a platform, where you will have a single ID and a single interface which can be used by any kind of persona. It can be your data engineers, it can be your data or data analysts or data scientists for that matter, or it can be also your business users who are used to generating those insights, all of them can come to this single platform, a single ID, where you can do the end-to-end, data management activities in a cohesive manner. So there are three main components that you will see here as part of Amazon SageMaker. There is a unified studio, which, like I said, gives you a single ID environment to do the end-to-end things. Whether it is SQL analytics that you want to do, you get the choice of various services to adopt, and you can decide for yourself whether you want to do use Redshift, Athena. I mean, it's as simple as just click and drop, where you can shift between Redshift and Athena if you want to do any kind of SQL analytics, or you can use EMR or Glue to write your ETL jobs or things like that. It also has your SageMaker AI, which was earlier SageMaker was mainly used for AI. That is now rebranded as SageMaker AI, and that is now integrated also with this new platform. Apart from that, any kind of generative AI applications that you want to build, Amazon Bedrock is a service or a platform which provides you access to all the LLMs out there, and that's also integrated in the single platform. The streaming services which we spoke about, MSK, Kinesis, those are also getting integrated as part of this platform, and you would see that coming soon within the next few months, right? So streaming applications, business intelligence, any kind of other services, all the services now will come together as part of one umbrella, which is called as Unified Studio, to access all of this in a seamless manner. What you will also have on top of Unified Studio is a layer called as Data and AI Governance. So do check out and read about SageMaker Catalog. Essentially, it is built on Data Zone as a service which was launched some time back, but it brings together your Glue catalog, your lake formation, your Data Zone, all of it together in a single place, where you can manage your access, you can manage your permissions, you can manage all of your metadata, whether it is business metadata, technical metadata, operational metadata, and you can also discover your data through a catalog like experience altogether via the SageMaker catalog, which empowers your data and AI governance in this platform. And then what we also have is a SageMaker Lakehouse, which is completely built open source via your Iceberg formats and Iceberg compatibility. So there is Iceberg catalog, there is Iceberg REST APIs, and as well as S3 tables, which I was talking about earlier. All of that come together as part of your SageMaker Lakehouse. So this end-to-end platform helps you do everything, right from your data processing to your ingestion and consumption. Everything comes together through a single unified experience. So just wanted to highlight that for people who are unaware, do read about this and learn about this, because this is the way forward. And the reason we want to invest in this future is also because all of this that you're seeing on the screen is empowered by Amazon Q, which is basically a service helps you do any kind of processing or any kind of model development. Anything can now be, or all these services that you are used to using or seeing in the AWS parlance, is now embedded and integrated with Amazon Q. So for example, if you want to author your ETL jobs or scripts, you can basically use a natural language to within Amazon Q to essentially create those ETL jobs and scripts within, say, AWS Glue. Or if you want to debug your ETL jobs, you can easily do that using Amazon Q, which is integrated, and you can simply type natural language kind of queries and essentially get responses to what is going wrong or what is going right in your ecosystem. You can also essentially generate queries like SQL queries via your Amazon Q. So Amazon Q, like I said, is integrated everywhere, which basically makes it easier to do all these tasks in a seamless fashion. So which is another benefit that you get. And finally, I mean, with all of this, what I want to leave you with a thought is we are also investing is in a zero ETL future. So if you have not read about it, I urge you guys to look at zero ETL. So zero ETL essentially is a future where we are seeing that all of those data pipelines that you build to ingest your data, whether it is your databases or enterprise applications from where you're ingesting your data, So you don't have to configure those data pipelines. You don't have to maintain those data pipelines. Essentially, what you will have to do is just have to make some tweaks on your source side, make some tweaks on your final destination, whether it is a data lake or a data warehouse, and your data seamlessly flows between both parties, whether from your source to target. You don't have to configure any kind of data pipelines in between, and that is what we are calling as zero ETL. Today, there is a limited set of sources and destinations that we support from a zero ETL perspective. But since, like I was telling earlier, we are committed to this future, so you will see more and more data sources getting added which are compatible with zero ETL, and both on the source side as well as from the destination perspective. We are already supporting applications like SAP, Salesforce, which are like third-party applications, and you can easily integrate, without creating any data pipelines in between to get data between these systems into something like a Redshift, Amazon Redshift. And same way, if you want to, use any kind of databases that you might have like RDS, Aurora, or anything that you are using, you can seamlessly get that data into Redshift today without building any data pipelines in between. So do read about this. So this is definitely going to be a game changer going forward. And with that, I'll close my session because this is what I had. Some leaving thoughts. Just to summarize for you guys, the services that we spoke about, we spoke at length about KDS, the Kinesis data streams. We spoke about Firehose, Amazon Data Firehose. We also spoke about MSK, which is your managed service for Kafka. Three main services that you should be aware of. Apart from that, you also have something called as Flink, managed service for Flink. If you're intending to do any kind of data processing or streaming data processing along with ingesting and storing and loading your data, that's where Flink comes into play. And finally, you also have MSK Connect, which is kind of integrated with your MSK. This is specifically if you want to import or export your data out of your MSK cluster to, say, other services or other external systems. So this basically helps there. So those are the various services from a streaming perspective. Like I was telling earlier, I haven't specifically spoken about Kinesis video streams because that's a different service altogether when it comes to streaming applications. But if your interest is to process your video data, that is a service that you should also look at. Apart from that, there is also something called as KDA, Kinesis Data Analytics, which is also used for processing like your managed service for Flink. KDA, because it's been around for a long while, so which is where I haven't touched in detail about Kinesis Data Analytics. But if people are used to Flink, managed service for Flink is the thing that you should definitely look at. So with that, uh, if you look at it, there is quite a bit of breadth and depth of services that AWS provides to meet all of your needs when it comes to real-time data processing, data storage, as well as analytics. Thank you, guys. So that is all from my side. Sanchit, over to you.
Thanks, Annie. Thank you so much for giving that wonderful walkthrough and understanding of it. Before we wrap up, we do have some questions, right? Let me check up those questions. The first question is from Bhavesh. Hello, Annie. For the IoT application where data ingestion is very high, do you recommend Kinesis data stream or use SQS and Lambda fetching data in batch and then process it? Cost-wise, good option.
So, if it comes to your IoT data, if your use case is about getting insights in real time, then I don't think using Lambda with S3 will help. You will have to use something like a KDS or an MSK specifically because you're talking about huge volumes of data. So it's better to do that to ingest your data, and whether it is into your data lake or whether you want to generate insights in real time, it's better to use MSK or KDS rather than having Lambda and along with S3.
Yeah. Second question, what we have is from Kavi. Can you tell me how to get a job at AWS? What is the procedure and what should I learn? I'm a BSc graduate from India.
Okay, good one. I mean, good to see that there are people interested. So, I would urge you to look at the portal for careers. There, you will see a frequent listing of all the jobs that we have. If there is a job that you find, something that you are interested in, you will have to go through the process. Unfortunately, we all have to go through that. There is a hiring bar, so there is no other way out. So, you will have to go through the drill to get this job. Sorry, I can't help you beyond that.
Got it. Thank you so much. And again, just to add what Annie mentioned, Kavi, I think also the part of the reason is do join different communities what you have, the nearby community to you. So you also get an idea about there are different speakers from AWS will also help you to get understanding maybe if there is any opening in your team and you will understand different services and other perspective, right? To get some more deep understanding of different services. So
Just to add to what just Sanchit said, maybe what you can also do is through these user groups and communities, you can, basically have your profiles referred. So we also follow employee referral policies and all. So you can get your profiles referred through, these communities and essentially make sure that you are applying for the right position. What I would also recommend is, since you're just starting your careers, is to think about doing any kind of AWS certification specifically in your area of interest. So that definitely helps to learn more about your AWS services, and it helps in your interviews, in your further activities that you're doing to make a career here at AWS.
makes sense. So that's pretty much from the question. I think we'll wait for a minute more. Guys, if you have any further questions, please do put it in the chat. And again, if you have not subscribed or any of our social media platform, please do it so you get a latest update of when are the next sessions, what's the link to join, and all those kinds of good stuff. So I would say join any of it, but please do subscribe either of the thing. Either you do YouTube, either you do WhatsApp or Meetup, either of the platform. Please do it. And in case if you're watching this video on demand mode, don't hesitate. Please post your question in a form of a comment below the video. I'll pass on those questions to any by end of the day, and we'll have your questions answered even on the on demand mode. So I don't think there is any question which I foresee here. So I think with that, we'll wrap it up. Thank you so much again, Annie, for spending your weekend with us and helping us to learn about it. And guys, we'll also have upcoming sessions on similar track, different day in, day out, how a data engineer works in IT industry. We'll have different other sessions coming around. Absolutely, Annie is helping us to curate this list of sessions upcoming. So stay tuned. Please subscribe to us and looking forward for you to joining our upcoming sessions. With that, thank you so much. Have a safe weekend. See you all in the next session.
Thank you, Sanchit. Thanks for hosting me.
Thank you.